Today's air travel is plagued with delays. Every day, more and more people take to the skies. And with global air traffic projected to double over the next decade, the reality is it's only going to get worse. Air navigation service providers, or ANSPs, are responsible for maintaining the safe passage of over 2.2 billion passengers each year, and are struggling to respond to the capacity demands placed on their surveillance infrastructures. While many ANSPs have turned to traditional technologies for their air traffic surveillance needs, some pioneers have adopted new technologies to aid their quest for safer, more efficient skies. At a time when most ANSPs were relying solely on radar, the Czech Air Navigation Service, or Czech ANS, was looking to the next generation. They were looking at multilateration. In the mid-1990s, the Czech ANS started its search for ways to significantly improve its surveillance coverage throughout the Czech Republic. Air traffic controllers needed a comprehensive view of all aircraft and vehicles on the Prague airport surface. Surface Movement Radar, or SMR, was simply not up to the task. It lacked complete coverage with significant blind spots. Adding to the challenge, the airport was planning new terminals and other construction to support more flights and more passengers.
As the airports become more and more complex, the ground movement radar is not capable of covering all the space, which means that it has to be supplemented by different sensors.
In Ostrava, air traffic controllers lacked terminal air coverage, as the secondary surveillance radar, or SSR, could not provide coverage below the surrounding mountain range.
The coverage by standard radar is from flight level 60 and above. It means for the lower flight levels up to ground we had no coverage.
Additionally, the Czech ANS had only 2 SSRs for the Prague terminal area. If either radar were to malfunction or require maintenance, surveillance coverage and redundancy would degrade. The Czech ANS needed another source of surveillance.
We had 2 alternatives, or to buy new MSSR, which of course will have limited use due to the terrain ring around, or to start with a multilateration.
Despite radar's status as the accepted industry standard, the Czech ANS began exploring the benefits of multilateration, which had already been proven for decades in military applications.
There is a very good record of the use of this technology in the Czech Republic, both on the side of the industry, but also we as the ANS.
We were one of the first who recognized the potential of this new concept.
Multilateration calculates an aircraft's position by the time it takes a transponder signal to arrive at several sensors. This principle allows multilateration to track any transponder-equipped aircraft or airport vehicle. The system is backward compatible with existing radar transponders and forward compatible with next-generation ADS-B avionics.
It is very flexible technology and it's very complementary to the classical surveillance.
Unlike secondary radar, where a massive mechanical antenna rotates every 5 to 12 seconds, multilateration sensors provide continuous tracking and can remain completely passive.
Radar is also a very sophisticated equipment, but it still requires moving parts, it requires a huge power, and multilateration is something completely different. It works with the signals which are available anyway, has no moving parts, and it's just the data processing system.
Whereas multiple specialized radars were needed for specific surveillance applications, the same multilateration sensor could be used for en route, terminal, and surface coverage. This allowed the Czech ANS to leverage their multilateration investment and easily expand the range of their network.
This technology uses the number of sensors instead of one radar site.
Given the flexibility of the system, the Czech ANS was able to seamlessly integrate its multilateration surveillance data with its ATC automation system.
multilateration provides you with a very accurate information which can be amalgamated with radar information.
The difference in between multilateration and radar, in fact, it's none from operational reason. It means for the controllers we have exactly the same picture and they are not able to recognize what is what, if it's this data are from multilateration and this from radar or vice versa.
Multilateration also functioned flawlessly in extreme terrain and weather conditions, while allowing the Czech ANS to fulfill its coverage requirements at dramatically lower costs than was possible with traditional radar.
It's a very cost-efficient solution. And as the pressure on reducing the costs of air traffic management, I think this is a system which could help very much.
It allows good sharing of the cost, good type of cooperation between the ANS providers.
After consistently exceeding performance expectations, the system was certified by the CAA against the radar standards of ICAO and Eurocontrol.
We were in very close cooperation with the CAA for the procedure for certification. The first was type approval and then operational approval.
There were hardly any hiccups in this certification process. So we finally succeeded, and the system is now used not only in Prague but also at the regional airports and also by other authorities as well.
Today, the Czech ANS multilateration systems continue to operate reliably with trouble-free maintenance, proving multilateration can not only supplement but provide superior surveillance over traditional radar.
I'm sure that within 5 or 7 years we will start with a stepwise decommission of classic radar. We will have a one-to-one the airspace covered by multilateration and classic radar, and later on, maybe 10-12 years, the multilateration will be on the top.
Thanks to the pioneering spirit of ANSPs like the Czech ANS, multilateration is shaping the future of air traffic control.
We are one of the first users and we are definitely ready to continue in this pioneering role.
In 1999, the Czech ANS commissioned the world's first surface multilateration system in Prague. In 2002, the Czech ANS deployed the world's first wide area system in Ostrava. In 2006, the Czech ANS extended the Prague system to implement the world's first combined wide area and surface surveillance system.
The multilateration is the future, and you can visit us, you can see this too.
Through their groundbreaking achievements, the Czech ANS has shown the world that multilateration provides a proven alternative to traditional radar and a seamless transition to ADS-B today, while guaranteeing backup and validation for the future.
It's spreading not only throughout Europe but also globally, because this principle is now well known.
The world's leading ANSPs are now deploying multilateration systems around the globe, realizing benefits never before possible, and launching a new era in surveillance.